So we are solving systems of equations today, and excuse me, to solve a system of equations, today we're doing it by graphing. There are other methods. Today we're doing it by graphing because we've just been doing all this graphing. We might as well continue. All right. So the solution to the system is where two graphs intersect. It's you graph two things and they're going to intersect at a what? A point, an ordered pair. That's going to be the solution to the system. It's going to be an ordered pair. So that's what we're going to be looking for. So you look at question A, and there are two equations, and you look carefully at both of them. What kinds of graphs are they going to give me? Points, right. So the very first one is in standard form. So since it's in standard form, I am going to do x and y intercepts. If you want to take standard form and change it around and make it into y equals mx plus b, you want to do that extra work, you can. I'm going to do it with x and y intercepts. It's up to you how you want to graph the line. So 3x minus y equals -4. I'm going to do x and y intercepts. My x-intercept, plug in 0 for y. I get -4/3. 0. My y-intercept, I'm going to plug in 0 for x. And I get +4. And my slope, remember slope is what in standard form? Negative a over b. So I do -3 over -1, +3. And I look at my information. It looks easiest if I'm going to graph my y-intercept at 4 and then use my slope from there, up 3 over 1. Ooh, you need something. You know what you need? It's really, really important. Yeah, I'll hand out the straight edges, but we are going to need the straight edges today. I don't care how good of a line drawer you are, you're going to need them. All right. If you don't trust me, somebody who's taught for this is my 17th year. Find out the hard way then. Everybody not take one? Oh, they look the same, except for, I need one more. They look the same, except for they don't have the domain restriction. So we are literally putting two equations on this one. Did you guys hear what Avery said? She said something that was really good, and probably what other people were thinking. She said, I thought that these were doing piecewise, because they look exactly the same as piecewise. Except for the piecewise have x is greater than something, or x is less than something. So the piecewise only tell you to graph part of it. These are graphing all of it. So we're going to use our straight edge. Be very careful when you connect that line so it is accurate as possible. Then my second one is already in the form y equals mx plus b. So I'll just begin at my y-intercept, my b. 0, -3. And I will move with my slope up 2 over 3. And as I'm graphing my points, oh, it crosses exactly at one of the other points I graphed. It doesn't always work so nicely. But this one did. So I think I know my answer. I think I know my answer. I think I do. I think I do. But I'm not sure. But I think I do. I think it's at -3, -5. I keep saying I think, because here's the thing. Has anybody in this room ever graphed and made a silly mistake? Oh, no? Okay. You know, maybe you accidentally put the y-intercept on the x-axis. Maybe the y-intercept is at 5 and you graphed -5 for some reason. Like, maybe the slope was negative and you graphed it positive by accident. Silly mistakes are easy to make. if I graph two lines and one of them has a mistake on it, and I think my answer is somewhere, how do I know for sure that that really is my answer? You have to check our answer. So it does say in the directions, check your solution in each equation. So we are going to check the ordered pair -3, -5 in both equations. So I'm going to check it in the first equation. 3 times -3 minus -5 equals -4. So I get -9 plus 5. Yep, that one checked. Then I will check it in the second equation. -5 equals 2/3 times -3 minus 3. -5 equals -2 minus 3. Yep, that does equal -5. So if it checks in both equations, then you have the right answer. It checks them both. Now, in my last class, I'm telling you the truth here, in my last class, I had people checking it in one equation and saying, yep, I have the right answer. And then I came over and I said, check it in the other one, and it didn't check. Because they had graphed one of them correct. So of course that point does check in the one. But the other one they graphed wrong and they didn't check it in that one. So you've got to check it in both to know if it works. Questions? We ready to go on? Go on. Too much fun? Having too much fun?
Oh, yeah. Can't control myself.
Yep. All right. So the next one, we're looking at our equations. And we say, ooh, these look fun. Those are in standard form. So you can either change them to y equals mx plus b and give yourself some extra work, or just find x and y intercepts and slope and graph it that way. Totally up to you. I'm going to do x and y intercept. So for the top one, my x-intercept, I plug in 0 for y. My x-intercept is -8/3. 0. My y-intercept is, I plug in 0 for x, I get -8 over -5, so I get 8/5. Neither of those are very nice numbers. I better find my slope. My slope is -a over b, -3 over -5, so 3/5. So here's where having a straight edge is very helpful. We're going to graph this as accurate as we can. But it's going to be hard because it's all fractions. So take your time. -8/3 is -2 2/3. We're going to go over on the x-axis approximately -2 2/3. Do your best. On the y-axis, 0 8/5. That's a 1 3/5 or 1.6. Do your best. I would maybe suggest let's use the slope to find a couple more points. So you can use the slope off of either of these, and we're going to go up 3 over 5. Just be as accurate as you can. Or we could go down 3, left 5. So this would definitely be one where I'd want to use my straight edge on because it's all fraction-y and I've just got to be as accurate as I can. And we're all using pencil, so we do make a mistake. Easy to erase. Now what? Second equation? X-intercept, -22 over 2 is -11. So on the x-axis, I'm going to pull out -11. It's off my graph. That's all right. We'll be okay. My y-intercept is -22/5. Which is -4 2/5 or -4.4. And I don't feel comfortable just connecting those, so I'm going to use my slope. negative 2 over 5. And I'm going to start from negative 11 because that one's exactly at a point. So I'm going to start at negative 11 and go negative 2 over 5. Hopefully, as you're doing that, you get aha. Hopefully. As you're plotting it, you go, oh, I think I know what the answer is. So here's another thing about graphing that's just kind of hard is if the answer is a fraction answer, if it crosses at there's fractions in real life, right? There's fractions on this graph somewhere. If it crosses at a fraction, how are you ever going to find it? You say, I would use a different method to find it, which we'll do next week. Do you guys remember doing substitution or elimination? You got it. Right, you've heard it. It'll come back to you as soon as we do it. But I've only given you graphs that will cross at integers so that you can find it. So as you're looking, if it's close to graphing or intersecting at integers, that's where you want to guess. So if yours didn't graph exactly at integers, like if it didn't cross exactly at integers, guess something close. And I say guess because after we guess, what do we have to do to make sure? So I think it's at -6, -2. So we'll check it. We'll plug in -6, -2 into both equations. If you are using your calculator the whole time, you are not going to help yourself in the long run. Because at some point, when we're not allowed to use the calculator, you're going to be in trouble. Check's in one of them. Checks in both. Don't have the right answer. Mm-hmm. Friday.
Go hard, girl. I gotta go.
You ready to go on? Next one is not a line. What do we got? Yeah, the second one is a line. The first one's quadratic. It's a parabola. And I've only given you questions that you should easily be able to use transformations with, the stuff that we just had a test on. So I see this parabola does not have a stretch. It's just like the normal parabola. What's the negative? Tell me. The vertical reflection reflects in the x-axis, so it's going to go down. And then what's the +5 tell me? Here's that 5. So I can just take that normal parabola, flip it down, go up 5, and plug it. I didn't even need a table for that one because I wasn't multiplying anything, I just proved it. Random comment about parabolas, or squared numbers in general. So, you know, you plug in 1 and you get out 1 squared 1. You plug in 2, you get out 4. You plug in 3, you get out 9. Do you know that the difference between each perfect square is the consecutive odd numbers? So from like 0 to 1, it's 1, but from like 1 to 4, it's 3, and then from like 4 to 9 is 5, and then from 9 to 16 is 7. Like, did it like,
Yeah.
doing that all day, I don't know why, I have no idea what's going on. But anyway, that is a pattern that may be helpful to help you graph faster. Okay, the second one, graphing by x and y intercepts or put it into slope-intercept form. I'm just going to do x and y intercepts because it looks easy. My x-intercept would be 1, and my y-intercept would be -1, and my slope would be 1. And as you're graphing, you should be saying, aha, ha ha ha, I know where they cross.
You have to say it in that voice.
It's really up to you. Don't really require a certain voice, but the eviler the better. It's kind of fun. So we have 2, 1, or we're guessing it's 2, 1, and -3, -4. But I say guessing because we could have graphed wrong. So we just need to check our answer. But there are 2 answers. So you have to check both answers in both equations. Stop your whining. Both answers in both equations. Here's my checks. Yes, 4 checks. So I'm going to first check -3, -4, and then I'll second check 2, 1. There we go. So my first equation, -4 equals -3 squared plus 5. So -4 equals -9 plus 5. Yep, that works. And second one is -3 minus -4 equals 1. Yep, that works. And then our 2, 1 equals -2 squared plus 5. So that's going to be -4 plus 5. Yeah, that works. And then we have 2 minus 1 equals 1. Yep. So we know we have the right answer. Oh, there's 2 answers. I would like to show you this little thing here. Definitely want to make sure you are prepared for your next course. If you're going to college next year, they're going to expect that you know this already. But the answer in set notation would look like this. Whoa, that didn't work over there. There you go. Set. Isn't that what I'm doing? That's what I'm doing. They don't have to be perfect. You know, I don't know if I've ever had a teacher that has been really strict about what order, but usually we just go left to right. So if you're walking left to right, it would be that one and that one. Yeah, if you need to get up and do it. All right, next one. First equation and the next one. First equation is what graph? We haven't done that one this year, but you have in previous courses. It is kind of a double parabola, kind of. Kind of. I mean, it's 2 things that go together.
A circle.
This one is a circle, and there is a way that we will make, you said an oval, it's called an ellipse in math. We will do that. We'll do that later. But this one is a circle. And I've given you circles because you had to do those in geometry and in algebra too. So you had those circles before. This one is a circle. We know it's a circle because it's x squared plus y squared. The circle has a center at 0, 0, unless there's a transformation with the x's or y's. And there isn't. It's just x squared and y squared. Then the radius comes from the number that it equals, but it's not 9. The radius, does anybody remember? It is 3. You square root the 9 to get your radius. So you go to 0, 0, use a radius of 3, just go up, down, side to side, 3. And draw your best circle freehand, because unless you brought a compass. That was not good. It doesn't really need to be absolutely perfect. We just have to figure out where it crosses with the other one, and hopefully it crosses at a point that is an integer. Because if it's not an integer, then either I messed up when I gave you the homework, or you're wrong. Hopefully I didn't mess up. I spent my time making it up. I don't know. Hopefully I didn't. All right, so the second one is what kind of graph? What kind of graph's the second one? Square root. And is there a stretch? No, it's just a translation which way? Right 2, down 1. So you take that, maybe right 2, down 1. So right 2, down 1, it's going to start here, and then we just draw our parent function. And you go, ha, ha, ha. Where do you think it crosses?
Right there.
I think it's at 3, 0. So we plug it in and check. 3 squared plus 0 squared is 9. Yep, that's right. And 0 equals square root 3 minus 2 minus 1. So square root of 1 minus 1. Yep, that's right. I know. This is the third time I'm doing it. Magic pen this time?
Okay. Oh. That's fine.
What did it do?
I'll do it again. I'll do it again.
Oh. Look at that.
Why you doing such a good?
That was better.
Yeah.
It doesn't work. This is magical. Like when you would spray the invisible ink on your white shirt, that little black ink that was here.
Okay. All right, last one. That's not, oh yeah. Last one is, what's the first equation? We've got x with something squared plus y squared equals 25. That is a circle. It just has a translation. So the center is not at 0, 0. Where's the center going to be for this one? Right 2. Correct. And then our radius is not 25. What is that? 5. So you go right 2, and then up 5, right 5, down 5, and left 5. Second equation is a line. We could find x-intercept, y-intercept slope, or we could do y equals mx plus b if you change the order. Totally up to you. Oops. So we're going to begin at 0, 1, and then down 3 over 1. Aha. Up 3, left 1. Aha. How many answers? 2 answers. Yep, I think -1, 4 and 2, -5. I think. How do I know? How many numbers am I checking? How many ordered pairs am I checking? 2 in how many equations each? 2, so I'm checking 4 total things. Yep, they check. Okay. I'm going to write my answer in set notation. I just want to get you guys your assignment started. So -1, 4, and 2, -5. So the assignment is a worksheet. I'm gonna pass it out, 7 questions. You got time to start it. I'll scroll back up. Yeah, you won't be able to read my check. I used my messy handwriting for that, sorry.
That looks like doctor writing.
That looks right.
Yeah, you laugh, but then I grade your papers during your test, and that's what happens if you write. Some of you. There's actually 2 pages, but there is a second page, but they're not stable.
Was the stapler broken again?
No, I just got sent through at 2 different times. The second page is coming. That's not second page. That's not second page. Second page is, Jake's passing out second page things here. Yeah, I went fast. I went fast so that you could start it in class. So now you need to start it in class. How to make it so good and amazing.
We did the 0 and then you went.
Wow.
Oh, from that 2 to 0. Okay.
Wow.
Yeah, it'll come out everywhere.
Thank you.